Okay, look at that guy. I'm a little worried this might be a long one. There's 16 slides, so let's just jump in there. We're not going to name any of the animals. Oh, don't you just want to draw on his little nose? Secret word? I don't know. We'll find out. So, to simplify an expression is to rewrite the expression without parentheses or negative exponents. Got to remember the distributive property and how to combine like terms. Let's see what that means. So in this, we're simplifying the following expressions. We know how to do that, right? We do 2 times 3, go to our houses, a to the negative 2, a to the third, b squared, and c to the negative 2. Now, when we multiply, we see we're going to have some exponents that are negative, so let's take care of that. 2 times 3 multiply is 6. Let's add negative 2 plus 3. Oh, that comes out to a positive 1. It stays up there. B to the second is there, but that C needs to go to the bottom, down to the bottom, and become positive. Over here, we're going to look at the Q's. There's more Q's on the bottom, so we're going to leave them down there. 7 minus the 2 that would cancel is 5. There's only r to the fourth up on top, and look at that 2 to the third. That means 2 times 2, which is 4, times 2, which is 8, and it's on the bottom. It just looks better if you put the number in front. It's called the coefficient. Put it in front, make it look good. You can be a pro. Okay, on C, there's nothing to clean up in the house, so I'm going to take negative 2, give it the third power, a to the fourth, give it the third power, and b to the second, give it the third power. Negative 2 to the third is negative 2 times negative 2, which is 4, times negative 2, so that's negative 8. Remember, numbers can be negative, don't care where they are. This one we're going to multiply. 4 times 3 is 12. Got a creeper down here. 2 times 3 is 6. Oh my gosh, why didn't we do that slide? We know how to do it. It's called review, guys. Okay, now do you see the difference between those and this one? These have a bunch of minuses and pluses, so these are done differently. These are not just brought home to houses. On these, you're going to rewrite the first one. 4x squared minus 5x plus 6. Then, when you take care of the second one, if there is a negative here, that's the same thing as a negative 1, and you're going to distribute it. That's going to give you a negative 2x squared. Take that negative and distribute it. Remember, that means multiply. Negative 3x. Take that negative and distribute it. It turns it into a positive 1. Now we're going to combine like terms. There are 2 methods of thinking for combining like terms. One is, I'm going to take the biggest degree, the degree term, and I'm going to circle those. I've got 4x squared. I'm taking away 2x squared. That leaves me with 2x squares. After x squared comes x. There, well, that's supposed to change colors. Change colors. There we go. There's a negative 5x, and there's a negative 3x. So in my head, I'm putting together negative 5x and negative 3x, so that's negative 8x. Then the last one I have are my constants. I've got a positive 6 and a positive 1, so that's plus 7. If you do them in the right order, start with your degree term and puddle on down, it'll all be in standard form and you're going to be in super duper shape. Okay. So this first one, it's all good. It's in standard form, 6x squared minus 7x plus 8. Now we're going to look at this sign right here. That's the sign that's important. Because it's a plus sign, we're really just distributing a 1, so we just kind of don't even do that. We just kind of say, I've got a negative 4x squared, a positive 9x, and a negative 5. So all I did was get rid of the parentheses. There was no distribution to do, so I just sort of dropped them. So now if I'm going to combine like terms, I'm going to take the x squared because that's my degree term. 6 minus 4 is 2x squared. Then I'm going to go after x squared is just x. So there's a negative 7x and a positive 9x. Negative 7 plus 9 is plus 2, and that's my x, guys. And the last thing I have is my constant. A positive 8 minus 5 is positive 3. Now notice when I'm adding and subtracting, the variable terms are staying the same. This is why. If you take, let me think. What can I draw? I really can't draw anything, so I'm going to draw an orange because it's orange. If you take an orange and you add another orange. Okay, they look like potatoes. Just choose whatever you have. What do you have? You have 2 oranges. They don't change. They're just oranges. When you're adding, you're just counting how many of those things you have. When you're multiplying, you're changing what you have. So here we've got a 4x plus 2. Whoop, look at right there. This is the big thing. This is a minus, which means I have to put a -1 and distribute it. So that makes it a -2x squared. Take that -1 and distribute it, makes it a -8x. Take that -1 and distribute it, makes it a +3. Now, as I'm glancing through this, my highest exponent is the squared. So I'm going to write -2x squared first. After 2 comes 1. That means there's an x to the first, there's an x to the first. 4 minus 8 is -4, and what was I adding? I was adding the x's. Then the last thing I have is the constants. I've got a +2 and a +3, which gives me a +5. This is really nice to do on your surface because you can highlight them. I don't have a highlighter in here, so you have to just do circles. But they're colorful, aren't they? Oh, look at all those little kittens. Okay, so we're going to start by just rewriting the first one. 8a squared plus 4. This is a plus sign. That means I'm just going to bring everything right down. Plus 6a cubed minus 3a squared plus 1a minus 2. And now when I look for my degree term, well, Jackie, whoops, I should call myself Mrs. Evans, shouldn't I? That was a cubed. Oopsie doodles. Be careful there. Be careful, careful, careful. So that's my degree term, the 6a cubed. It comes first. After 3 comes 2. So here's an a with the 2. There's an a with the 2. 8 minus 3 is a +5. And what am I adding there? The a squares. Then after 2 comes 1, so here's the only guy without just an a, so I have plus 1a. And then the very last thing is the constants. I've got a +4 minus 2. 4 minus 2 is 2. All right. It's our halfway point, and we're only at 7 minutes. Maybe we've got a shot at this not being too bad. All right, this one's a little bit different because it's the distributive property. Look at this, 3x is being multiplied by this whole polynomial. So I'm going to take the 3x and I'm going to give it to the -2x squared. So it's 3x times -2x squared. Then it's a +3x. I'm going to now multiply it times well, that was supposed to change colors. I hate it. You can hear the pen hit, can't you? -4x. Then we're going to take that +3x, distribute it all the way down to the end, times a +6. Then if you look at this, we've got houses. Right here, if I just ignore all this, and this was my only problem, I'd be putting 3 and -2 in a house, x to the first and x squared in a house, right? 3 times -2 is -6, and how many x's are in my house? 3. Now I'm kind of ignoring this, and whoops, don't do that, and ignoring this because this is my next term. Remember, terms are separated by those pluses. So here I've got a 3 and a -4, and I've got an x and an x. So 3 times -4 is -12, and that gives me 2 x's in that house. Done with that. Now here, this last term, I've got a 3 and a 6 and just an x. 3 times 6 is 18 with an x. So you know how to distribute. You've done stuff like this before, 2x squared plus 5, when you just multiply the coefficients. This time you have to multiply the coefficients and add the exponents. So the secret word is wowzer. Lots o' work. That's an R. That's a horrible R. ... But it's fun. Happy face. So I guess it's a secret phrase. Okay, next slide. So now look at this. It looks like there's nothing to do, but way back here is a little monomial, and it's being multiplied. That's what those parentheses next. Look at his face. I love him. Oh my gosh. That's because he's in shock because the monomial's in the back. We're going to distribute from the back to the front. So I'm taking n squared times 2n squared, because that's what was in the back. Then I'm going this way. It's a positive 4n. And what was I distributing? Now, distributing means give to everybody, remember. A 2n squared. Go to this next one. There's a negative 6. And what am I giving him? A 2n squared. Then remember, each terms are separated by pluses. So I stop when I get to that plus sign. I'm multiplying. So I have 2. And then how many n's? 1, 2, 3, 4. This term, 4 times 2 is a positive 8. How many n's? 1, 2, 3. The last term, that's a negative 12. And how many n's? 2. Has to be in standard form, remember, biggest down to smallest exponent. Okay, here's our monomial that we're going to distribute. So we're taking 5f squared. Look at this guy. He's so calm. He goes, you got this. We know how to do this, guys. We're machines. Plus, we're taking that 5f squared and giving it now to negative 2f cubed. Plus, we're taking that 5x squared and distributing or giving it to f squared. Plus, we're taking that 5f squared and giving it to the negative 1f. Remember, if there's no number, you're going to put a 1. Now, here's a plus sign, so that means everything in front of the plus sign I'm going to multiply. The only numbers I have are 5, so it's 5. And then how many f's are there? 2 plus 5 is 7. I'm going to go to this term next because that's in between these plus signs. This one I'm done with. 5 times negative 2 is negative 10, and then how many f's? 2 plus 3 more is 5. Done with that term. Here's the next one in between plus signs. So it's a plus. There's a 5. How many f's? 2 plus 2 is 4. Done with that one. And at the very end, I've got 5 times negative 1, so that's a negative 5. And then how many f's? Remember, there's a 1 there, so 2 plus 1 is 3. This gets confusing. When do I add exponents? When do I not? So here's the rule. When you're multiplying, you add. When you're adding, you don't. Crazy! I feel like I might have missed. Was that a checkpoint? That might have been a checkpoint. Oh my gosh, you guys. I am really helping you out here. Okay, now this one is, I bet that was a checkpoint. Oh my gosh. I'm not redoing it. We are 12 minutes into this. I'm not redoing it. See this minus sign? Look at the difference between that minus sign and these. This one is inside parentheses, so it's part of that binomial. This one is inside parentheses, so it's part of that binomial. So this minus right here is outside, and what that's doing is separating the problem. So over here, I'm going to distribute. I'm going to take 3m times 5m, and I'm going to take that positive 3m times negative 4. Then I'm going to distribute this term right here. That's a negative 1m squared. So it's negative 1m squared times that 1m. Going back to that negative 1m squared, and now I'm going to multiply it times the 3. Okay, so plus signs. Plus sign, minus sign, minus sign. Plus and minuses, remember, kind of do the same thing. So I'm going to look at this little term, that product of monomials. 3 times 5 is 15, and how many m's? 1 plus 1 is 2. Now I'm going here, in between the plus and the minus. 3 times negative 4 is negative 12. How many m's? 1. Okay, between the minus and the minus, I've got minus. 1 times 1 is 1. How many m's? 2 plus 1 is 3. And then at the very end, I've got a negative 1 times 3. That's a negative 3. How many m's? 2. Now this should just drive you crazy because you've got two little guys with m squares and you've got this huge m cubed. Well, that huge m cubed has to come first, right? That's our degree term. These two little guys with m squared, I'm going to combine like terms. M squares are the same things. I got an m squared, I had another m squared, I still have m squares. 15 minus 3 of them is plus 12. And what was I adding? M squares. And then the only thing I have left is minus that 12m. Mind blown. So much happening. Okay, look at this little guy. Oh, guys, you know what? I didn't do a checkpoint because this is checkpoint 1. Yay, me! Look, he's a little worried about it. He thinks you don't have this. He is wrong. His name is Wrong Ricky. We're spelling Ricky funny. Wrong Ricky, because you got this. You can do this. Let me give you a hint. Put a 1 here and distribute the -1, okay? Pause it. Do it. You got it. Okay, welcome back to example 3. I feel like I've done more than 3 examples, but this one's called. Uh-oh, guys. Uh-oh. These are equations because they have equal signs. Wow, this is a long unit. Whew, look at that's what this guy's going. Oh, I'm turning gray. I'm getting so old doing this unit. All right, I'm going to separate. I'm not even going to look at that side. Over here on the left-hand side, I've got the distributive property. So 1x times 2x is 2x squared. And 1x times 3 is plus 3. Then I've got a plus 20 over here. Now I'm going to go over here and I'm going to look at the left-hand side. So now I'm not looking at this. I've got the distributive property. So 2x times x is 2x squared. And 2x times -3 is -6x. Okay, so what you do first is you distribute. We did that last semester. We know that comes first. The difference is we've got lots of variables this time. After you distribute, you're going to combine like terms, but you're only looking at one side at a time. So on the left side of the equal sign, these two things, Evans, that was supposed to be 3x. So nothing can be combined, right? Look at this side. Can anything be combined? Nope. Not after I fixed my mistake, they can't be. So now I'm going to move the x squared from the right over to the left. I do that by subtracting it. So minus 2x squared. You know what, guys? You could have gone from the left to the right. It doesn't matter. These two cancel. These two cancel. Look, he's starting to smile. Because what do I have now? 3x plus 20 equals -6x. And I know how to solve that. I'm going to subtract the 3x. You know how I know you know how to solve that? Because you passed first semester. 20 equals -9x. When you divide by -9, your answer over here, because I'm out of room, is -20 over 9. You're just going to move the negative to the top because we don't say 20 -9s. Remember, we get beat up in the lunchroom. We don't want that to happen. So say it the right way. Oh my gosh, guys, we still have lots of slides and we're in 18 minutes. Go, Evans, go, go, go. All right, separate left and right. Distribute. 3 times y is 3y. 3 times -2 is -6, and then there's a plus 2y. Notice how I went a little slower because I messed up last time. Then there's an equal sign. Oh, look, over here, there's absolutely nothing to do but rewrite it. 4y plus 14. I can't put them together. One has a y and one doesn't. There's no distribution, no parentheses and times. That's all I got. Let's go to the left-hand side. This time I didn't mess up. This time I can combine like terms. I can put 3y and 2y together. So 3y plus 2y is 5y. There's still a -6 equals 4y plus 14. Oh my gosh, that's so last year, Mrs. Evans. We did this all in August and September. We know how to do it. Okay, show me. You're going to subtract the 4y. Cancels over there. 5 minus 4 is 1y. We still have -6 equals 14. You're going to add the 6. So y is equal to 20. Why? We now know the answer, 20. Okay, some definitions. Wow, you're going to write this stuff down. This is going to be a lot of writing, so you might have to pause a few times, okay? Natural numbers. Natural numbers are the set of numbers. They're counting numbers, which means we don't put fractions or decimals, and they start with 1. I'm going to tell you why. If I ask my 4-year-old grandson to start counting, guess what number he starts on? 1, then 2, 3, 4, and he keeps on going. You know why? Because he's brilliant. Just ask me. I'll tell you all about it. Okay, but then he's going to go and he's going to find out, now that he has a little sister, sometimes he doesn't have any toys because she takes them all. So whole numbers are the natural numbers, which means they're the counting numbers, plus we have now included 0. All right, so if we say start counting in whole numbers, you're going to go 0, 1, 2, 3, 4, and so on. Notice they have no fractions or decimals. Integers, well, you know what? I'm sitting here making this video and it's snowing outside, which means it's doggone chilly. So on our thermometer, we might need negative numbers. It might be a negative wind chill. So integers are your positive and negative counting numbers. So you got 0, 1, 2, 3, 4, but now you've also got -1, -2, -3, -4, and so on. So now we've learned that sometimes people take things away from us. Okay, if you notice all of these, so that's this set right here. The natural numbers are the first. They're part of the whole numbers because we just add 0. They're part of the integers because we add positives and negatives. But none of those have fractions or decimals. There's no fractions or decimals. No fractions or decimals, people. Until we get to rational numbers. Now, rational in English is a word that means it makes sense. A very rational person makes sense. So what you've got, I just looked at the cat. He's just so cute. I don't know where Mrs. Colonis found these pictures. They're so adorable. All right. So rational numbers include certain fractions. They includes all fractions and certain decimals. Okay. And I'm going to put a little asterisk above decimals because it could be special. So it has to be any number that can be turned into a fraction. So a rational number, 4 is rational because it could be over 1. 3 is rational, it could be over 1. 2.5 is rational because we can turn that into 5 over 2. 0.333333 is rational because we can turn that into 1/3. So it includes decimals that either end or repeat because those can all be turned into a fraction. Irrational numbers are non-repeating, it's supposed to be terminating, but I don't have room, so I'm going to put ending decimals. My husband's in the other room laughing at me because he thinks I'm a moron. He doesn't know I'm the CEO of the ID10T Club. You do because you watched that video. Okay, so for example, 4.7632189.4. I don't know what the number is. That doesn't make sense. This one makes sense. I know the next number is 3. So that's irrational. Pi is the most famous irrational number. The square root of 5 is an irrational number because we don't know what that is. The square root of 4, it goes up here because it's rational because the square root of 4 is really 2. So see how the irrational numbers are over here? That's because they make no sense. So they don't even get to play with the rational numbers. They're all real. Everybody's real. Keep it real, guys. Boom, boom. Okay, I'm going to go with this is probably a checkpoint, which means you go. Okay, look at that guy. He looks tired. You should be too. This was a 24-minute video. Wowzers! Okay, have a wonderful day. Bye.